Greetings and welcome. We were talking about like postulates and diagrams and things that you should believe are true without any proof, but are so obvious that it's like, yeah, that's believable. So here we go. It said for question 3, state the postulate illustrated by the diagram. So this says if there are 2 points, then there's exactly one line that passes through them. And since we are still familiarizing ourselves with these postulates, it looks like that's the 2-point postulate. So through any 2 points, there exists exactly one line. So we'll call that the 2-point postulate, right? Postulates are accepted as true without proof, and I think like these are all pretty believable. They're not like huge leaps in logic or anything like that. Let's see. It says use the diagram to write an example of the postulate. So this is, they asked for the line point postulate, which I believe is the one that says that any line contains at least 2 points. Yeah, a line contains at least 2 points is the line point postulate, right? So they're really not like going over the top. They're just like, yeah, that makes sense. Let's see, the only one that has points labeled on it, I could say Q contains, so line Q, this line right here, contains J and H or J and K. I'll just say J and K. Right? Just kidding. And then the line intersection postulate. All right, yeah, I see that. We're good. We're good. Line intersection postulate. Two lines that intersect. These being distinct lines, not the same line, have a point as their intersection. So I could say P and Q intersect at H. Right, so this is just a matter of kind of being familiar with these postulates. Let's verify that line intersection postulate just to get familiar with it. Yeah, so 2 lines, if 2 lines intersect, then their intersection is exactly 1 point. Wonderful, wonderful. All right, ooh, sketching. Here we go. Excellent. Todo de los personas estás aquí. All right, welcome, welcome. So it says, let's draw a diagram of the description. So I'm going to draw a plane, P. All right, so usually when you draw a plane, you draw it as kind of like a parallelogram or something like that. So here's plane P. And then it says XY in plane P. So there's a segment, XY. So it looks like this, X and Y. Just any old 2 points on that plane, and I'll draw that segment. And it is bisected by point A. All right, so bisected means point A is going to be at the midpoint there. I could even label that these two XA and AY are congruent to each other. And then it says, and there's a point C not on XY. To emphasize that, you probably should draw it outside of your parallelogram so it looks like it's floating above it. Yeah, that's probably the best way to do that. Or you could even like theoretically draw like another thing like that. Question, comment? And point C. Oh, sorry, my bad. My bad. Yes. Because, yeah, although, yes, point C here is not on XY, it's also true they only said it didn't have to be on the segment XY. I was drawing it as though it wasn't on the plane. My error in judgment. So, yeah, so this is kind of more the descriptor of what's going on. It's theoretically, C could have been even collinear with them, but just not between points X and Y. All right, so yeah, good catch, man. Mr. Waddy's got to just read these instructions a little bit more closely. All right, here's another diagram regarding 3-dimensional things and things that we can assume based on the diagram. All right, so it says points K, L, M, and N. Let's find where those fellows are here. K and L and N and M. They ask, are these coplanar? What are your guys' thoughts? Yeah, I know through, at bare minimum, by postulate, that any 3 of them will form a plane, right? That they would exist on a plane. But the fact that all of these happen to be on plane X appears that that is true. So yes, on plane X. Okay, so that is true. How about this next one? MN and RP intersect. So MN was this one here. Yep. And RP is this one here. Now, depending on your visualization, you might be like, hey, there's an intersection right there, right? But that's not the case. Yeah, because you can tell they're on two separate planes that have this intersection at this line, and they don't intersect at the same point on that line. So this one is like kind of floating on top of RP. So this is false. This is no. You can't assume that. That's a sad-looking false, but that's fine. And then how about this last one? NKL, angle NKL. Come on, Mr. Waddy. There we go. So there's NKL. The angle, is that a vertical angle with JKM? What are your guys' thoughts? I'm getting a head nod. Yeah, because they share a vertex and they form two pairs of opposite rays, one pair and another pair. So true. This is true. And I don't know what angles those are at. There was a question about perpendicularity, I think, on one of these, but it's not labeled, so I couldn't assume it. So yeah, so I do not know what those measures are, but I definitely know those are vertical angles. Let's see. Ooh, man, my friend. I love having friends. Guys, this is great. Your friend claims... Oh, sorry, I thought this was my friend, but it's your friend. My bad. I thought I was friends with this person, but I guess not. I thought we were closer than this, but I guess I was wrong. Okay. So your guy's friend claims that even though two planes intersect in a line, it is possible for three planes to intersect at a point. Is your friend correct? What are your guys' thoughts? I find sometimes drawing multiple planes intersecting, drawing some sort of prism or pyramid is helpful. So let's see. So here's one plane. I'll call that the blue plane. Right? Here's another plane. Those have a common intersection of a line. That's true. And then if I have this third plane over here, it intersects with this one at a line and this one at a line. But the common intersection between all three is going to be a point. And we know that that's kind of like an application of the, what was that? The line-point postulate? Point line? Man, I've got to memorize these names. Line intersection postulate, right? So the fact that those planes intersected to form a line, plane intersection postulate, and there were multiple lines, those lines happened to intersect at a point. So I'm just going to say yes, and my verbal explanation will suffice because my writing is not entertaining or that educational. Thanks for watching, friends. Bye-bye.